Welcome to the session, First City on Mars, Urban Planning on the Red Planet with Professor Justin Hollander. I want to remember you, if you have questions or comments for our presenter, please type them in the chat box and he will address them during the Q&A session at the end of the presentation, okay? So it is an honor for me now to introduce Professor Hollander, Justin Hollander. He is professor at Tufts University, and he has recently published a book under the same name of our presentation, The First City on Mars, an Urban Planner's Guide to Settling the Red Planet by Springer Praxis book. So yeah, without saying more, thank you so much, Professor Hollander, for being here. You have half an hour, including Q&A, and the room is all yours. Yeah.
Okay, well, thank you, Mauricio, and thank you all for joining this session. So my plan is to talk a little bit about some of my research around urban planning, and then have time at the end for Q&A. I do need to acknowledge a team of students that helped with this research. So kind of before we launch into Mars and space, outer space planning, let's just talk about what is urban planning. So, when you see an image like this is actually Boston. It seems like it's kind of like jumbled, like there's buildings here, buildings there, traffic lights, streets. It's not actually an accident what you see, because it came to be because of a plan. And today, all over the world, the same kind of planning happens. Cheyenne, Arapaho Master Plan. This is what we do in my field. We bring together different voices of opinions. We look at data and information and knowledge about different scientific concepts, different aspects of society or sociology or the environment, and then come together and agree on some sort of goals for how that change is going to happen in the coming decades. So what about for Mars? I mean, it's not really that different. There's not the same kind of community engagement that you would have necessarily. Though of course we can talk to people on Earth about what they want to see on Mars. So that's what this presentation is about. Is really doing a plan for the city of Mars. And what does it take to do that? Because the fact is that people are going to go, and the other fact is that Mars is very inhospitable. And that one thing we can say about a couple millennia of planning for cities is that it can help, that it can ensure that a settlement can be more safe, more successful, and more healthy than something that's more haphazard and not planned for. So as an entry to kind of talking about what this involves, it's helpful to think a little bit about colonization. And that word has a very strong stigma today. But let's just talk about what does it mean in terms of the movement of a population from one place to another. It's about understanding that when humans go to Mars, we are going to be colonizing it. And we have a lot to learn about colonization throughout world history. And in my book, I talk about these three major epochs of colonization. So the ancient Greeks between 900 and 500 BCE and 400 CE, colonized throughout the Mediterranean. The Chinese between 1000 BC and 800 CE colonized all over East Asia. British colonization of Oceania and Eastern United States in that later period. So for you guys, what I want to do is just walk through a couple key points from the first one, that first ancient Greek and Roman colonization, see what lessons we might be able to learn that can be useful for Mars. So first of all, when the ancient Greeks and Romans, when they colonized, they looked for things like access to water. Then that's both for transportation purposes and for drinking. And this is from Homer. Odysseus's ideal location for colony is deserted, a plethora of meadows flat enough to plow, dense forest, wild goats, a cove that serves as a natural harbor. So obviously, when we're talking about Mars, we're not going to be able to find any place where there's some wild goats. But these are the things that they thought about. And of course, access to mines and metals, where for Mars, that is actually relevant. Gellius in 177 CE said Roman colonies are reproductions of Rome herself. So it's really a facsimile, what you see of ancient societies trying to replicate themselves. Generally, they identified plots that were about 125 acres. So, right, this is really kind of standardized. And they built them as networks along the sea, which was, of course, the transportation route. And this is an example. Typical Greek Roman colony. They had a lot in common, more in common than they had difference. They're encircled by walls. So security is always going to be a consideration, typically between 6 and 8 feet thick. The famous Forum, that's kind of in the middle there, roughly about 300 by 120 feet, and it stretches along a main north-south road, which is called the Cardo Maximus. And that Forum is going to be flanked by government buildings, which is called the Basilica on one side, and the religious temple, open-air public building place, local Senate House, and amphitheater all on the other. So you can see this kind of arrangement of all these civic uses. So we're going to draw on this as we think about in Mars. Do you have some kind of like main kind of cardinally oriented roads that connects an entire place? And what kind of uses? Are they going to be religious? Are they going to be public meeting? Are they going to be governmental, right? So these are the considerations. And just a kind of bird's eye view and the plan view, I just want to show you what that looks like. You also have an additional large road that's going to connect to an entrance, which is going to be a fortified citadel where another temple might be placed. And then you also have a series of these minor roads. They're called the Cardo and the Decumus. So it creates a grid pattern, right? The grid pattern is quite ancient. We see that in many cities today. And here's the interesting thing. Why do we know all this stuff? We know it because it was written down. Vitruvius was actually one of the best scribes of the ancients in terms of communicating what these plans all involved. So he talked about a lot of things in the 10 books of architecture, but a few specifically about city planning. One is that forum, that plaza, be rectilinear, as opposed to, say, in a circle, and have a ratio of about 3 to 2. The plaza should be located near the water. Again, we've talked about this, but in coastal areas. But in cases where they were not coastal colonies, the plaza should be in the center. And then that public building should be prominently placed around the plaza, which we saw that in those images. So we can extract some really important lessons. And these lessons I'm going to show you here aren't just from the Greek and Roman experience, but from those other ones I studied as well. And so a lot of these things are kind of emphasized, but thinking about the site selection, thinking about street design, public spaces, prominent public buildings, and then spirituality. These are all things that we can kind of take with us in approaching a new plan for a new city on Mars. So part of the research that I did for this book was looking at that history, but also kind of looking at contemporary perspectives on what it takes to build a city on Mars. And that's earlier kind of when I talked about what is planning, what does it do? It does that kind of look at science, society. What's the conditions in this place? And transportation is a big challenge because of dust storms, extreme temperature, radiation, all that's going to happen on the surface. Subsurface does have challenges around tectonic movements, but on Earth, we've largely been able to overcome those. So we expect that we would as well. So what I want to do is just give you a couple of slides to give you a flavor of these kinds of challenges. So here's one about society. You know, what you see a lot in a lot of new development in cities, new areas, is mixed use. But you also saw that for most of human history. It was only the last 100 or so years where that kind of separation of uses really predominated. But yeah, so the idea of here in this case, vertical mixed use. So on the first floor, you have some sort of retail, restaurants, Second floor might be office, and third and fourth floor might be residential. A building, there are a lot of construction challenges, but at the same time, opportunities. So here is an illustration of a very ancient approach to building that allows for you take advantage of the reduced temperature fluctuations underground, but also getting some energy from the sun and light. Certainly a lot of challenges around breathing, drinking, and eating. So here I've just shown you just an example of what's called the gas extractor schematic. Just this idea of some sort of closed loop, which International Space Station, ISS, we've got a lot of experience, a lot of research has come from that, but not even in outer space, on Earth, in mines, underwater. Humans have come up with some really good ways to create these closed loops where we can extract air, we can take out important components, and we can reuse it and then create water and other byproducts. So I took all of these different ideas and principles, and then I wanted to see, what about other designs? I'm not the first person to ask this question of what a city on Mars should look like. So I wanted to kind of show you guys all some examples. ZA Architects entered this competition, and what their idea was, let's build underground, but then have these kind of skylights that help provide some light and potentially some heat into these interior spaces. Pretty drab, but basic. Icon partnered with a firm Big, and here there's some below ground, but there's also above the surface, like a dome-like structure. Zophorus, this is shares its name with like a bug. A lot of these dome concepts. What's notable here is kind of like a series of domes around kind of a central hub dome. Prairie View University, their students entered this NASA contest, and they published this, what I thought was just really, really clear, crisp concept that really did the same thing, where there is a subsurface. We also have the above ground, you have the dome structures, but all the domes are all kind of connected by these tunnels, and you're able to have a lot of different activities in the domes. Kozikia wrote this dissertation that so took that idea and just really poured a lot into it and kind of introduced this module concept where it's essentially like these 3 domes, and they're connected by this kind of central unit and that central module where rovers can kind of come in, and each has a range of uses, mixed and singular as well. And this is just so very well researched and just very much grounded in some really good science and engineering, and very scalable. So I developed in this book 20 principles that were based on all of these lessons: the science, the engineering, the society lessons, based on the colonization history that I read about. And I could have stopped there, ended the book here early, but I did continue. I developed a plan for a city on Mars, and that's just because people need that. It's not enough just to have a list of 20 principles. So this is what it looks like. Using a lot of the kind of concepts that were shown earlier, the same kind of 3 domes with a kind of a central unit, all kind of connected, but also these kind of utility domes. A lot of stuff happening below the surface. I'll just zoom in here so you can imagine, like, one is for greenhouse, one is like for mining. You have a storage hub. But that kind of, each of these is kind of like its own unit, but that it's, again, very scalable. So very easy to be able to accommodate large populations by being able to keep repeating. And as these units need additional mining hubs, greenhouses, that's easy enough to add. And what you see on the surface here are rover paths, because even though we might not want to do a lot of transportation above ground, I think one thing we have learned on Earth is that is probably going to be the most common way people will get around. But we also want to be able to create a subsurface transportation network, both cargo and for civilians. So we're imagining all this kind of excavation would happen beforehand, and that they'd be able to lay out these tracks that would connect all of these different settlement blocks, and then again, easily scalable to be able to connect to like essentially a large city. So here up, imagine up a drone up in the sky, looking out, Olympus Mons in the background or something. So this is essentially kind of our vision of kind of what those principles like in place could look like. Of course, infinite number of other kind of possibilities, but just to kind of illustrate. And I have some images just to hopefully grab your attention. So you're essentially, people are living under these domes, for protection. At night, the radiation is not a problem, so that's not an issue. A lot of green. A lot of my research showed how important the psychological dimension is to living on Mars, and the way you do that is you make it feel like Earth, because we are of Earth and we need to be near these kinds of Earth-like features, and that's what biophilia, love of nature, is all about. And here you see inside a little bit more. So you have grass, you have trees, parks, and yeah, maybe even you could even ride bicycles. It'd be a little different experience than on Earth. And you can see here when you have this kind of mixed use, you might have on that first floor retail and restaurant, second floor might be office, and then up on that third floor could be the residential areas, where people live. But you have to have recreation, so some of these domes would have different types of parks, and some would have maybe ball fields, and here in the case of a basketball court. And so the vision here is that you can continue to grow and expand the settlement using that kind of density level, and so much about what that initial settlement unit tells us is it provides for that resilience. And when you're in a situation that's so hazardous, you don't need to build a giant skyscraper of sorts. That kind of smaller scale is more effective and be able to protect health and safety of the people who are in that space. So here you have the ability to kind of spread out, since there's definitely plenty of room, and that's kind of the vision. I'm happy to answer questions or take any comments for the rest of our time.
Thank you so much. That was great. So we already have some comments in the chat. I don't know if you want to read it and address it, or do you want me to do it? Yeah.
Yeah, you can.
Yeah, of course. Okay. So yeah, I have a first one. It's just a comment. It's this is so cool. I imagine the Minecraft generation will be great at this. And another one. Oh, sorry. Do you want to comment on that, or I should?
No, I agree.
Yeah. Okay. So yeah, the other one is, did you choose a particular site on Mars? Site selection is a very involved process within the planetary science community. And
yes. No, go ahead. I'm sorry.
Okay, one more, and I let you to answer. Another one. This was really great, like very informative and inspiring. And finally, second question. Thank you for that. That was outstanding. Will there be issues shipping trees to Mars? And that will be it. Yeah. Thank you.
Well, we'll start with the last comment. I mean, I don't think you would ship a tree. I think you would ship a seed, and that you would cultivate. You could partially grow it during the trip. But yeah, I mean, we're not talking, you would not have the kind of 40-foot trees that I show here, initially, but after 10 or 15 years, that's the idea. Yeah, so in the book, I talk about, I have this like whole section on site selection, and go through a bunch of different possible locations, focusing a lot of the ones that have been kind of contemplated, Gale Crater, Holden Crater, Mars Vallis. And so we ended up deciding on Utopia Planitia. And that was really just because it had the most kind of attractive location for like a few reasons in terms of the latitude. It helps with the landings. It was kind of one of the largest kind of flat areas of Mars. That also made it attractive. Communications are easier in that kind of environment. And the radiation shielding is a little bit better up there in that part of the planet. So I'm sure there are a lot of other good places to start, but that was just the one that we offered.
Thank you so much. A couple of more questions. The water will be mined from passing asteroids.
Yeah, I mean, I didn't see a lot in my research that suggested that would be the best. But I think that is a possibility if, in some cases. There's quite a lot of H2O in the Martian atmosphere and in the Martian regolith, and also subsurface. So I think that's kind of the consensus that I've read, that you can extract it in situ. You don't need to go to an asteroid, but to the extent that asteroid mining makes sense, that I'm sure that would just that would help.
Okay, thank you for that. Wow, a lot of different questions. Let me give a read to it. Do you think we will eventually terraform Mars? And another one related, should architecture be planned or allowed to develop organically? For example, the aesthetics and not just utility. Yeah.
Yes. Well, I'm definitely a big fan of letting the architecture develop organically and to respond to the local conditions. There are some basic principles that are important as part of the first city, because the first city, to the extent that it connects to vernacular and traditional architectural patterns on Earth, it will help people with the adjustment. It'll put them at ease. So, there are certain ideas, bilateral symmetry where the left and the right side are the same. That's something that's been a hallmark of architectural design since antiquity. Having hierarchy, the low, the middle, and the top. Again, that's been part of architectural design, classical design, and vernacular designs of buildings throughout human history. And then it's hard to imagine that humans would thrive without being able to see that. And then there's many others, and I've written about this in another book, Cognitive Architecture, where we kind of lay out like what is the science behind different designs. So as long as that those vernacular, the kind of Mars vernacular develops in a way that kind of recognizes humans and our innate need to see certain types of forms, shapes, colors, then I think that would be great. I think that would be exciting. And in terms of the other question, terraforming, yes. I'm not sure how many of you are fans of Kim Stanley Robinson and his Red Mars, Green Mars, etc. series. But I find that line of thought very compelling, that the Martian environment is not currently very welcoming to humans, but we have proven that it is actually possible to change the climate of a planet. And so I think that is a realistic way to make Mars more attractive and habitable for humans.
Awesome, thank you. I think we have one more question, probably the last one. It says, realistically, is there a consensus or goal of when we will expect significant progress towards habiting Mars at the level presented? Yes.
Yeah, I mean, this is not soon. And I think that many of us were really astounded by what Elon Musk was able to accomplish, especially last week, but just, in his couple decades at this. So I think that it's fair to expect that in the coming decades that humans will land on Mars. It will take time before that first landing to start building cities, but I'm thinking within my lifetime. We'll see.
The questions keep coming. Let's try
Good,
to
right?
answer most of them. Yeah, I have this one that says very impressive. Will not be better if the order of stages is reversed in the buildings and the ground floor is used for residential, since it is more protected against rays and also more stable temperature. And another one, how will humans make the atmospheres breathable? Thank you.
Yeah, so you're definitely right, and I did emphasize that early in the presentation that being underground is safer. So yes, there in those illustrations I showed you, I didn't show you the basement, and I didn't show you the sub basement and the sub basement. So I think you would expect there to be levels going down, and that would be a much more ideal place for people to live than because then you're more protected from radiation. So it's a very good point. The other question, I'm sorry, where was that? Well,
Yes,
how do you breathe the air?
yes, that's it. Atmosphere.
Yeah, I mean, there is an atmosphere on Mars. I mean, it's very thin compared to our current one, but it is possible to extract the necessary amounts of oxygen to be able to mix it with other, gases and nitrogen and etc. to be able to create breathable air. It's a labor-intensive process and does require quite a lot of energy. So there are certainly challenges and barriers to be able to create that kind of breathable air on a scale. I'd like to tell people that when they talk about, people ask me about water a lot. That there was an interesting kind of Mars analog project that finished just about a year ago. And they were able to do with massive amounts of energy, more than it would take to run a Bitcoin farm. They were able to take an atmosphere that was equivalent to the Martian atmosphere and extract water. And over the course of like 6 months, they were able to extract about a teaspoon of water. Okay, so not quite ready for a prime time, but the technology is there. We're just not quite ready on a mass scale to be able to support a city of the size that I'm talking about here. But humans are quite ingenious, and I do expect that as we get closer and closer to that first launch, a lot of these engineering problems will be solved, and I think that it is possible that people may be able to live on Mars.
Wow, that was great. So thank you again for your presentation, Professor Justin Hollander, and thanks to all the attendees for this magnificent conversation. So now we need to close the session, and remember, this is the perfect time for a short break, as the next sessions will begin in about 10 minutes, okay? So thank you for everything and see you around.
Bye.